Hi, so let's start first of all talking about Python syntax. The first thing we want to do is print hello world. To do so in Python, all you have to do is type the following. Run, and there you have it. This is the first important thing about Python, how to print to the console. Now the second important thing is indentation. So what I just wrote is not the same as this. You would see that Python will throw an error, which is indentation error. Now, what does an indentation mean in terms of Python? It's used usually to indicate some sort of block of code. So for instance, let's say, let's say, if 1 is greater than 2, print hello world. Run, and I don't see anything. So indentation is used when you have a block of code inside some sort of conditional or loops or a function and so on. We'll talk more about those in the coming sections. Now let's talk about some other types of syntax such as commenting. The way you comment in Python is using the hashtag symbol. This is a comment. Then we have something like print hello world, run, and as you can see, Python skipped this block of code. Now the second thing we want to talk about is variables. Unlike other programming languages, Python has no command for declaring a variable. So you don't say int x is 5, this is not allowed. All you have to do is say x is equal to 5, and you'd leave Python to figure that out. So 5 is seen as an integer, right? This is an integer. Here we have name is equal to, let's say, Ahmad. Python figures that out as a string, right? And y is equal to 5.0. Python would figure that out as a float. So how would you know if a variable is an integer or a string or a float? You can use the type command. So type of x is int, type of y is float, and type of name is an str, which means we have a string. Now let's talk a bit about numbers. So let me remove all those, run. So in Python, we have three types of numbers, which are ints, floats, and complex numbers. So x is 1, as we said, this is an int. 2.8, this is a float. And 1 plus j, or 1 times j, is a complex number. So for those of you who are not familiar with what complex numbers are, they're just numbers with real and imaginary parts. So to verify that z is a complex number, print type z, it's complex. This means that we can perform addition, subtraction, multiplication, and whatsoever operations with also complex numbers. Okay? Right, so let's talk now about casting. What does casting mean? It simply means that if I have let's say I have a float and I would like to cast it to be an integer, all I have to do is y is int x. Therefore, y will take the integer part of x. To verify, print x and print y. Run, we have x is the float and y is the integer. To check, type of y is int. This is useful when we want to, for instance, concatenate two strings, for example. So let's say I have first name is Ahmad and last name is Bazzi. So my full name will be first name plus some white space plus some last name. So this will return my full name. But let's say I would like to also append, let's say, an integer at the end of my name for some reason. Then let's say x is my integer, 1. All I have to do is say plus. If I say x, we'll have an error. So running that, I have an error because strings cannot be concatenated with integers. So all you have to do is say strx. This means that the integer x is now a string. and there's no error. Let's print out my full name with the number appended in the end. There you have it, Bazzi 1. Okay? You can also cast an integer to a float as such. X is 2. Print the float of x. Run, it's 2.0. Okay? Now let's talk about some strings. So as we saw, strings are nothing other than an array of characters. They're just letters concatenated to form one string. Okay? So let's say I have my string uh, last name or full name is, and print full name. I have my full name. Let's say I want to print part of my full name, 2 till 5, run, and there you have it, mad. So 2, remember that Python counts starting at 0. So 0, 1, 2, M is at 2, A is at 3, and D is at 4. 5 is excluded from the count, so 2, 3, and 4. Okay? This is for string indexing. You can also get the length of my name, which is 11. We have 11 characters. You could strip. So strip, what strip does is that it removes any white space from the beginning or the end. So if I had a white space here, run, there's no white space here at the beginning. If I have a white space at the end, there's no white space. To verify, let's get the length of full name.strip at the end. It's also 11, like my name, without the white spaces. But there's a white space in between. That's okay. It won't strip it out. It only strips from the beginning and from the end. That's useful when you have, I don't know, maybe a user who kept an annoying user who kept inserting a white space at the end to exceed the limit of the allowed characters, right? So all you have to do is strip them out and strip this out. Okay? You've got as well the lower method, lower, without the len, run. It converts any uppercase letter to a lowercase. Similarly, you have the upper, converts everything to uppercase. Okay? You've got also the replace function, which will replace any occurrence of a character with another character. Let's say D, run. So uppercase A is replaced with uppercase D. Let's put lowercase a, run. So my lowercase a's are replaced with an uppercase D. Okay. You've also got the split function. So split, all it does is it returns an array of strings which are splitted upon a certain character. So let's say my character or string is the white space, run. I get an array of my first name and last name. Let's say I want to split at lowercase a, run. I get AHM right here, then a D white space A, then there's an A right here. It's not, it's going to split there, then a double ZI. So an array of 3 strings. Perfect. So let's say now you are interested in reading some user input. If you want to interact with the user and you want to ask them to enter some sort of number or string or whatsoever. So all you have to do is, let's say, print. You're asking the user about his name. What is your full name? And the user will enter his name. So name is equal to input, right? So the input inserted in the variable name, then print a greeting message. So let's say greetings plus name, right? So run. Now the program is paused right here, waiting for us to enter a name. Let's say run. So there's an error. And what is it? So the problem here is depending on your version of Python. If you're using a version of 3 plus, higher than 3, then this should work out. If you're using version 2.7 or 2.8, you should, instead of input, type in raw underscore input, and all should go well. So run again, and there you have it. Okay? So that brings us to operators. How to perform operators in Python. So let's say I'd like to perform some addition. Let's say I have x equal to 2, y is 3. So let's print out the following. X plus y, print x minus y, print x times y, and print. By the way, in Python 2.7, it's okay not to insert brackets over here. Okay? It's not an issue. But I think in Python 3.6, no, it should be there, right? So you should do this. On the safe side, always put some brackets, okay? And last but not least, x divided by y. Run. There you have it. X plus y is 5, x minus y is minus 1, x times y is 6, but x divided by y is not 0, 0.6. And why are we getting that? It's because we're dividing an integer by an integer, so the output should be an integer. To avoid this, we have to do some casting, so float x divided by float of y, so that we get an output which is a float, right? Okay, so those are the basic operators. You could have some more advanced operators, such as the modulo, like x modulo y, which is the result, which is the remainder upon dividing y by x. Run, it's 2. Then you have the exponentiation, which is x power y, as such, using 2 asterisks. Run, it's 8. You've also got floor division, x, 2 forward slashes, and y. Run. So let's increase x a bit. Let's put it 10. There you have 3. It's the integer part. It's the smallest integer. It's the largest integer that is closest to x divided by y. Okay, so x divided by y is 3.3. What is the smallest integer or the floor integer that is close to 3.33? It's 3, right? Let's do 11. It's also 3. 12 would be 4. Okay. Now you got some assignment operators. So what are assignment operators? X equal to 12 is one assignment, right? We're putting the value of 12 in x. You've got other types of assignment. Let's say you would like to increment x. All you have to do is do x plus plus, run. We have an error here, which is, also you can't print x plus plus. So let's say x plus plus as such. So in Python, there is no such thing as x plus plus. In other programming languages like C, C++, Java, JavaScript, and many more, this is equivalent to x is equal to x plus 1, right? Well, in Python, you should do this. In case you want to increment, all you have to do is this, or the shorthand notation, which is this. Okay? So after this, x should be 14. It's incremented here once and then here. So 14. This is how you increment x. Okay? You could also decrement x. So let me remove this. Decrement it using a minus. It's 11. You could perform multiplications. Of course, 12 times 1 is also 12, 12 times 2 is 24, times 3 is 36, and so on. Of course, all this, you could do it using the longer notation, which is x is equal to x times 3, right? You can also perform division as such, modulo, and so on. Okay? Now let's talk about some operators, some Boolean operators, or that are related to Boolean algebra, like if a certain statement is true or false, for example. Now, let's print the following statement. Is 1 equal to 1? It is, so it's true. Is 1 strictly greater than 1? It's false. Is it less than 1? It's also false. Is it less than or equal to 1? It's true. Okay, so what did we do so far? We are writing some sort of statements that evaluate in the end as true or false. We've got 6 operators, Boolean operators, which are the equal. So let me put here, let's say x is equal to 14, y is equal to minus 15. The first one is testing if they're equal. The second one is testing if they're not equal. Third one is testing if it's greater than, strictly greater than. Fourth one is testing if they're strictly less than. Fifth is greater or equal. And last one is less than or equal, right? Put it like this. So run, I get booleans, either true or false. Okay? Now, if you want to have some composite, Boolean statements, right? You could use the AND operator, like AND x equal to y and x not equal to y. Of course, this is false. So what does AND mean? AND requires both statements to be true. So it returns a true, right? Else it will return a false. So if you require both statements to be true, you should use an AND. If you require at least one statement to be true, you should use an OR as such, right? Now, if you want the negation of a certain statement, so print not true is false. So let's print something which is not true. Is x greater than 15? No, it's not. So it will return a true, because not false is true. Okay? Now let's talk about collections or arrays. In Python, we have 4 types of arrays, right? We've got lists, we've got tuples, sets, and dictionaries. Those are the most common ones. Now, what is a list? A list is a collection which is ordered and changeable. We'll talk about what that means. Tuples is a collection which is ordered and unchangeable. We'll also say what that means. Set is a collection which is both unordered and unchangeable. And dictionaries is a generalization of an array that you typically know, which are indexed from 0 till the length minus 1, right? So dictionaries are widely used for storing key value pairs. They could be seen as hash maps or maps. They're used a lot when it comes to JSON or XML communication when you're communicating with some sort of databases or APIs, right? Dictionaries is what you want to use, and so on. So let's start talking about lists. So how do you define a list in Python? Let me just go put those down there because we're going to use them later on. So a list is defined as following. So let's say I'm interested in a list of fruits, right? So I've got apples, cherries, bananas, what else? Pineapples. That's it. Okay, I've got a list consisting of 4 items. Now, what does ordered and changeable mean? Ordered means that the the order that you placed your items in are respected. What does that mean? It means that apples is going to sit at index 0, cherries is going to sit at index 1, bananas at index 2, and pineapples at index 3. Now, this is what ordered means. Changeable means that you can change, you can modify content in your list. So let me show you what I mean. First of all, why is it ordered? So let's print out fruits sitting at index 0. It's apples, right? Because it's the first one. At index 1, it's cherries. At index 2, it's bananas. And index 3, pineapples. What happens at index 4? We get an error. Index error out of range, right? Good. So this is what ordered means. Now, what does changeable mean? It means you can change the content of fruits. So how do we do that? All we have to do is index the position we want to change. Let's say I want to change cherries to strawberries. Strawberries. And let's print out the fruits. Run. There we have strawberries sitting at index 1. Okay? Now, what other stuff could you do with the list? You could count the number of items in the list using the len operator. So we have 4 items. You could loop through a list. So let's say you would like to get each and every entry using a simple loop. So for a fruit and fruits with a colon notation, you could print fruit as such. Let's say you're interested in printing the initial of a fruit. There you have it, A, S, B, P. Okay? You could also add items. So let's say, let's index the 4th node, index, which is empty or doesn't exist, and put there, what should we put there? Let's put avocados. Now print fruits, and we get an error. This is not allowed. So the proper way to do it is using the append. So avocados, and print fruits, and there you have it. So you should use append to add, right? Now let's say you don't want to append at the end, you would like to insert it or squeeze it between items of the fruits. So all you have to do is fruits.insert, and first of all you should mention the index where you want to insert it. So let's say I want to insert it between bananas and pineapples. So this means it's at index 0, 1, 2, 3, right? So 3, what do you want to insert? Let's say avocados again. So let's print fruits, run. There we have avocados sitting between bananas and pineapples, right? Now let's say you would like to remove some items of the list. We want to remove apples, right? So we removed it. Now let's print to verify. There we have it. It's not there. Now you can also pop. What does pop mean? It means remove from the end. So print fruits, and there you have it. Pineapples is not there. Pop again. Strawberries is not, bananas is not there. Fruits pop again. Strawberries will not be there. There you have it. Now this is popping. Let's say you do not want to pop the last element, you would like to pop any random element. So all you have to do is mention the index of this element. So let's say you want to remove the element at index 1 right here. All you have to do is mention, I want to pop out this element. So run, there you have it. Everything is there except the element sitting at index 1, right? And you can also use the sort function, which sorts your list. If you have a list of strings, it would sort it according to alphabetical order. So run A, B, P, S. Okay? If you have a list of numbers, so let's say I've got some numbers, 10, 2, 4, minus 10, 0, it would sort it in increasing order. So numbers dot sort. Oh, sorry about that. You should execute the function, then print. Run minus 10, 0, 2, 4, 10. Now, if you want them in decreasing order, you could use the reverse, and there you have it. Reverse just reverts your list. So if you're not sorting and you just, execute reverse, you'd get 0, minus 10, 4, 2, 10. Okay? So that's it for lists. That's all you need to know about lists. Let me remove this, and let's talk about tuples. So what does unchangeable mean? Unchangeable. Unchangeable means you cannot modify a tuple. Once initialized, you cannot modify, right? So let me show you what I mean. Let's say I have a tuple, which is in Python defined as follows: 3, 5, 10. Simple as that, right? So to access an element, all you have to do is mention its index. So at index 1, we have 5. At index 0, we have 3. At index 2, we have 10. And at 3, we have nothing, right? And let's say you would like to modify, right? You'd like to modify 3, which is sitting at index 0 to 30. And you'd get this error, which tells you that tuple object does not support item assignment, which means that it's unchangeable. Okay? So when are tuples basically used? They're used to as outputs of functions. This is where they come in play. Now, we saw how to access elements. We could also loop through elements. So let's say you'd like to print it as just to check what's inside. You could do this, or you could do a loop for elements in a tuple. All you have to do is print element, and there you have it. Okay. Let's say you would want the length of the tuple using len. You would like to add, could you add items to a tuple? It's unchangeable. Can we add? Append is not there for us, so we cannot add. Okay? So that's basically what tuples are used for. It's as simple as that. Let's go to the next topic, which is sets. Now, sets are collections which are both unordered and unchained. Now, what does unordered mean? It's a very interesting thing to know what unordered means. Let's say I have my set, which is composed of the following: -4. So the way you define a set in Python is using curly brackets as such. So -4, 10, 3, 11, and -5. Let's try to print my set. My set, printing it out, they're not in the same order, right? So 11 is now in the beginning. So let me type minus my set at index 0. I cannot even access. So you cannot access at a certain element, and you cannot modify. So at index 3, I want it to be 10. You cannot modify. right? So that's what unchangeable means. And unordered, we saw what it means right now. Each element is not sitting at its position that we created it. So, so if I go ahead and do a loop for element in my set, print my element, run, we've got 11 being the first one, 3 being the second one, 10 the third one, and so on. This is useful when you want to include some randomness in your code, right? Because you have some sort of people arriving and you would want to put them in a random order, okay? You'd want to use sets in that case. Perfect. And you could also, can we count? Let's check. Length of my set. Yes, we could count the elements in a set, okay? Can we remove elements? Well, it's unchangeable. Let's try. Remove. Let's remove 3. It worked. Yeah, it worked. So you could remove values, not at indices, the value. So 3 is a value. So remove 3 and now print my set. 3 is not there. It's not at index 3, it's the element 3. Okay? Because if you would want to remove at a certain index, that's not allowed because you're unordered. Let's try popping. Can we pop? Run. And yes, it popped. It actually popped an element at random. Okay? So can we append? Let's check. No, we cannot. Can we add? Let's add 100. So it's being added at random. Okay? So that's how you create a set. You keep adding to a set, so they're there at random. Let's say you want another element to be added. Add minus 100. It's right here. Now add 0. It's here. See, they're being added at random. Add 44. It's here. So there's no pattern or there's no relation between the value we're adding and its index, right? So that's all about sets. Let's go to the most interesting and the most famous array type in Python, which is a dictionary. So a dictionary is a collection which is unordered, it's changeable, so we didn't type them here, it's unordered, it's changeable, and indexed. Okay? Now in Python, dictionaries are written with curly brackets, so let's say I have my dictionary, you use curly brackets, right? And you'd want to indicate some key value pairs. So let's say I have a key 1, which corresponds to a value of 10, then key 2, which corresponds to a value of 20, then key 3, which is a value of 15, right? Let's print a check. There we have our dictionary. Now it's unordered. We talked about what unordered means in sets. The order that you initialize your key value pairs are not respected. It's not respected. So key 3 appears in the beginning, key 2, key 1 at random. Okay, let's add some more keys. Key 4, 12. So key 4 is sitting here. See, it's at random. Okay. Now in dictionaries, we do not care about the order because the index is, so we can't say this is at index 0, we can't say this is at index 1. The index for item 10 or value 10 is the word key 1. It serves as a password, right? It's like a password. So the way I would like to extract 10 is by mentioning its key. So key 1 is 10. This is a key or a password. It lets you access the element if you know the key. Okay? So this is how you index or access a certain element or a value in your dictionary. Let's say you'd like to loop through your elements in the dictionary. So for I in my dictionary, let's print I. So it extracts all the keys. So I can name it key as well. For key in dictionary, print key. There we have all our keys. Let's say you'd like to print the values. So all we have to do is say my dictionary of key. There you have it. Okay. Let's say you'd like to print key value pairs. So print key is what do we call it? What is it? It's key. And value is my dictionary, and we should cast it to be a string because we're printing. So run, there we have it. Key 3, value 15. Key 2, value 20. Right? Now it's a changeable. We could change the values, so I could do so. My dictionary at key 1, let me change it to 20, or let me change it to 100, and let's print to verify. There we have it. Key 1 is 100. Let's say I would like to index an element which is not there. Key 5 or 5, and I want to print it. Run, we get an error because key 5 is not there. If you want to create it, all you have to do is this, right? So you just assign a certain value to the corresponding key. Now, if you would like to extract the length of your dictionary, you use len, my dictionary, run, and it's 4. Okay. You could also remove items from your dictionary. How do you do that? Well, all you have to do is my dictionary dot remove. No, it's not dot remove. All you have to do is do del my dictionary sitting at key 1 run, and then print to verify. So key 1 is not there anymore. So you use del or delete. You can alternatively use pop, right? So my dictionary dot pop key 1. There you go. You could do pop item. Now what did that do? It popped a random item, or it popped, yeah, a random item, and there you go. It pops random items. You could also clear your dictionary, so in case you don't want it anymore, you'd like to free it from memory, you would like to start adding from start or from scratch, you use the clear function. Okay. Now let's say you would like to get keys. It's not from keys, I think it's keys. Yeah, it's keys, yeah. So you get an array of keys using the keys function. Okay, so that's an easy way to extract them without looping, without doing a loop. You would get an array of all your keys. Okay. So that's it for the 4 types of arrays. Let's hop on to the next topic, which are conditionals. So conditionals. So what are conditionals? Conditionals are just blocks of code that are executed under a certain hypothesis. So if something is true, print hey, else print code. So as long as we run this code, it will never access this block of code. Print hi, print hello. So this block of code right here will never be executed given this program, because it will either execute this or that based on this statement. So this statement is always true, therefore it will execute only this block of code. Now if it's false, it will execute this block of code. So I will print ho, hi, hello in this order. Okay. Now, when is this useful? Let's give a simple example. Print get, or what is your name? \n means go to a new line. Then name is raw underscore input. So raw underscore input reads from the user. And then if the name is equal to Bazzi, which is my name, then print hello Ahmad. Else print you're not Ahmad, but you're most welcome. Okay, let's run. What is your name? Hello Ahmad. Let's run it again. Put Ahmad. You're not Ahmad, but you're most welcome. Okay, so this is an application of if-else statements. You've also got elif. Elif, or else if, it's typed elif. Elif means you're testing for another condition or statement. So elif, let's say I would like to test name. Let's split the name when there's a white space and test if it's Ahmad. Print your first name is Ahmad. Your first name is Ahmad. Welcome. Else print your first name is not Ahmad, but you're most welcome. Run. What is your name? Ahmad Bazzi. Hello Ahmad. So I'm here. Right. Now run it again. Ahmad. Give me a last name. Bazzi as such. So enter. Your first name is not Ahmad. So what happened here? This is an array. So to extract the first element of the array, all I have to do is index it by 0. So run again. Ahmad Bazzi. Your first name is Ahmad. Welcome. So you're here, right? Now let's run it for the last time. Michelangelo Bazzi. Your first name is not Ahmad, but you're most welcome. So you're here. Okay? You can also do some shorthand notation like so. It's the same thing. So this is equivalent to this. It's a more compact notation to indicate if-else statements. Now this is handy when you have only one line of code following the if command, right? It's more readable. But if you have a lot, no, don't ever do that. You should do this with indentation, okay? So let's say I have something else, x equal 1, print x squared, and so on. Do not ever put them on the same line as the if statement, okay? Because it's not clear what you're doing. It's not readable anymore. Okay, so that's it for if statements, else statements, else if statements. Let's go to something fun, which is looping. So what is a loop? Previously we saw looping in sets and tuples and lists, right? Loop is when you're executing a block of code multiple times. So a simple example on that is, let's say, let's initialize I to 0. Now while I is less than 9, keep incrementing I as such, and before that print the value of I, right? So run, and there we have it. I is 0, first of all. Is it less than 9? Yes, it is. Print it, right? Here we have it. Then increment I. Now I is 1. We go back to the while statement. Is 1 less than 9? Yes. Do the same thing until you're greater than or equal to 9. Okay? So instead of this, let me put 2 times, right? Run 0 to 6, because the next one would be 12. Okay? So it will not enter the block of code. So this is one type of looping called the while loop. It's really interesting. While loop. You've also got the for loop. So for loop is when you want to execute a certain block of code a certain amount of times, right? So let me comment this out. So how do you do that? For, let's say, I in a certain range from 0 to 10, print I. Let me remove this. Run from 0 till, but not including 10. Okay? Let's say you'd like to skip some values. Run, skip 2 values, so 0, 2, 4, 6, 8, the even numbers. Okay? This is all about for loops. We saw applications on for loops and arrays and lists, and so when we had a list, which is, let's say, this is not a list, this is a list. So 4, 3, 2, 1, 0, for example, and I would like to print the list. You could either do this till the length of list minus 1, print list of I, because I serves as an index. So there we have it, 4, 3, 2, 1. And 0 is not printed, so I should do this. There we have it, okay? Or you can do something much more easier without having to know the length of the list, without bothering if I should say length minus 1 or length, because in some programming languages you have to know that an array or a list starts from 1, whereas other arrays starts from 0. So to avoid all this confusion, so for item in list, print item, you get the same outcome. Okay? Perfect. So the next topic we will be talking about is functions. So what are functions? Functions are just some block of code that execute only when they're being called or executed. So let's say def my function. This is the blueprint or the skeleton of how you define a function. So define my function. So let's say I would like my function to print hello world, and then I would like my function to perform some operations, y is equal to 3, then print y plus x, and all that stuff, right? Then to execute this function, all I have to do is call it. My function, run, hello world, then x is 1, y is 3, then add them and print the output. Okay? Now this is a function that basically doesn't take any input and doesn't produce any output. So how do we include some inputs to my function? So let's say I have a function that returns full name. So full name of, it takes 2 arguments, let's say first name and last name. Okay? So all you have to do is print first plus some white space plus last. So now there's no such thing as my function, it's full name. This is the name of the function. So full name, first name Ahmad, last name Bazzi. Of course, there's no auto-completion for my last name. I thought there was some auto-completion feature. So run, and there we have it, okay? Now, this is a function that takes inputs but doesn't produce outputs. Let's say I want a certain input to be a default value, right? So let's say I accidentally did not enter my last name, and if I'd run that, I'd get an error, which is type error. You have to input 2 arguments. So let's say my last name was Bazzi. This is a type of way of setting a default value for last in case it's not passed in the main function. So run, and there you have it. When is this useful? It's when, let's say, you're adding numbers. Add 2 numbers. Or add 3 numbers, right? A, B, and C. Let's put 0 as default values. So this function could take no input, or 1 input, or 2 inputs, or 3 inputs. Not more and not less than 0, right? So print A plus B plus C. Now let's execute the function. What is 1 plus 1 plus 1? It's 3. Plus 2 is 4. Now let's say I accidentally did not input C. I'll get 1 plus 1 plus 0, which is 2. Accidentally I didn't input C and B. I'll get 1, and no inputs, I will get 0. Okay? That's a way of reducing errors in your program, right? Now, how do we produce outputs? So define a function that returns a multiplication of 2 numbers. So multiply, say A, default value 0, and B, default value 0, right? Return A times B. So C is equal to multiply 2 by 3. Now print my C, which is 6, right? Now let's say you want more than one output. You would want to do that using tuples. So let's say you would want to return multiplication and divide, right? You'd like to multiply A by B and divide A by B. So floats for division, right? So here it would return 2 numbers, C1 and C2. Multiply. So what is the error here? Oh, so it's multiply and divide, no longer multiply, the name of the function. So print C1 and print C2. And there you have it. Okay? The most common way of returning multiple outputs is using a tuple, as we did here. Okay? Another thing you might find useful are recursive functions. So recursive function. So what is a recursive function? It's a function. Let's say I have a function called factorial that calls itself, right? So a recursive function is a function that will call itself within the scope of the block of itself. So let me show you what I mean. So let's compute the factorial of a number using a recursive function. So all we have to do is, if n is 0 or n is 1, return 1, right? So because 0 factorial is 1 and 1 factorial is 1. Else you would want to return n times the factorial of n minus 1, right? So let's give this a try. Print factorial of 3 should be 6, right? 4 should be 24, 120, and so on, right? 1 should be 1, and 0 should be 0. 1. Minus 1, we're going to have a problem here, right? Because this function will never stop running. So you can see here, maximum recursion depth exceeded. So let's put a base case for this. If n is negative, then return 0. There's no such thing as a negative factorial. So run, we get a 0. Okay? So that's it for recursive functions. Let's talk a bit about lambda expressions, right? Lambda expressions. So what are lambda expressions? A lambda expression or function is a function that can take any number of arguments but can have only one expression. Let me show you when that is useful. Let's say you have a function which varies according to a certain variable. So let's say you have a function f of x, a function of x. The easiest way to define this function is using lambda expressions. So f is lambda x, or a function of x, and this function, let's say it's 2 times x plus x squared plus 5, right? So let's see how it works. F of 2 is 13, f of 0 should be 5, f of minus 1, and so on, right? This function could also have two variables, lambda xy, which means f of xy. You can also add your y wherever you please. So print f of x, or 2, 3, is 23, and so on. Let's say you accidentally inputted one argument, you'd get an error. So the way around that is by setting a default value, and there you go. Okay? Lambda expressions are also useful. Let's say you have a function of two variables. Let me remove that. F is lambda x, and it's simply, n times x. Okay? Let's say you have a function which takes n, def multiplier n. Okay? And here I have an error, which is I need a colon. So what this function does is that it will return a lambda expression. So it will return a function that depends on n, or x, given n. So let me show you what I mean. f1 is a function which is multiplier of 1. f2 is another function which is multiplier 2. And f3 is multiplier 3. Let me print f1 of 5, print f2 of 5, and print f3 of 5. So what should be the outputs here? Since f1 is an anonymous function, or a lambda expression, so you also could, this is alternatively called anonymous function. So if we have f1 being a lambda expression, f2 as well, f3 as well, it is this one for n equal 1, 2, 3 respectively. So we should be able to see 5, 10, and 15 as such. Okay? So that's typically it for functions. We talked about functions, recursive functions, and lambda expressions, right? Let's talk about something more fun, which is classes, right? So classes is like a generalization of everything that we saw. Classes are typically used in object-oriented programming languages such as Python, C++, Java, and so on. And a class is typically a constructor, or an object constructor. And another definition of a class is that it's a blueprint for creating objects. So let me show you what I mean. The type of way to declare a class in Python is using class. Let's call this class a class as such. And let's say the class just takes does x equal 5, right? So how do you instantiate a class in Python? All you have to do is type in a class, my class, or m, right? As such is equal to a class and such, right? No, that's not the way. So m is equal to a class and as such, okay? So in that case, we created a class, and therefore we can access its properties, right? So it has x equal to 5. So what's going on here? A class should have some sort of properties and methods. So this is typically used when you want to create some sort of new variable or new data type that does stuff. For instance, let's say I have a string. A string is, this is a string. So X is of type string, or we can say X is an object that belongs to the class string. Therefore, we could execute some stuff with X. We could, extract some stuff from X, one of its properties, and we could do some stuff with X, like return the length of X. So those are methods associated with X, right? More precisely, we could say perform uppercase, and then print X, or X as such, and there you have it. Okay, so it's as if you're creating a new data type with some properties and methods that belong to it. To understand more about classes, let's create a class called animal, or vehicle, right? A class called vehicle. And let's say this class will have some methods or properties associated to it. So what type of properties could belong to a certain vehicle? Let's say the vehicle could be, we could have, I don't know, number of wheels, right, is equal to 4 as initial value. Or if you want to create it upon instantiation, you want to initialize your variables upon instantiation, all you have to do is use the init as such, init, right? So init is like a constructor that initializes all your variables, right? So if you have a variable called number of wheels, you would define it as such. Number of wheels is equal to number of wheels, right? So what this is doing is that upon creation of a certain object of class vehicle, you should pass it number of wheels. Once you do that, it will store it inside the property number of wheels of vehicle. So let's change the name here, wheels, so that we avoid confusion. So wheels will be stored in the self property of this class, which is called number of wheels, right? Now, typically in most programming languages or in most tutorials, you will see that the name of the property being passed and the property belonging to the class will be the same, right? This is an easy way to avoid, confusion while you're typing the code. So we're going to name them the same thing, okay? Number of wheels. What else can we have inside a vehicle? We could check if it's invertible or convertible. Is this vehicle convertible? So self.is convertible is convertible. And another thing worth mentioning is that the type of the variables are not mentioned. So this is automatically inferred by once you create the class. So let's say, how does Python know that this is not a int, it's a Boolean? It's when you create the class. So now down here, when I want to create a certain vehicle, let's say car is a vehicle. And as you can see here, we should enter the number of wheels, let's say 4, and is convertible. Let's say you wanted true, okay? This is how you created an object car with those two property values, right? Let's say we want some more type. Say this is a string, maybe. And down here we should enter the type. Let's say it's a BMW. Okay, this is enough. So that's it for properties. Let's go down to methods. Let's say I want a method to print all my properties. So def print all properties. So print self dot number of wheels, print self dot is convertible, and print. So I seem to have an error here because it's highlighting self. I should pass it as a argument right here, and it will solve the trick. So let's be more informative here. Let's add number of wheels is, since it is an int, then we have to cast it as such. Then is or convertible, then also cast, and type. There you go. Okay, and let's say you would want to have another method. Let's say we want to move the car. Okay, so we have also a position of the car, which we will set to 0, and we will have it one-dimensional for sake of simplicity. So that's one more property, position equal to position, and print the position as well. Okay, and you would want to do a method to move the car, move car. So if we want to move the car, we should tell it by how much we want to move it. So dx, and here self dot position is equal to self dot position plus dx. Okay, right. So if I didn't pass the position right here, it means it will be 0 by default. Okay, so running this, we should get no error. Good. So this is how you move a car. You just increment it by a certain distance. Let's say you want to, let's call this move forward, right? Moving forward. Let's do another one, moving backward. Self dx, and instead of moving forward, instead of adding, I would subtract. Let's say I would like to pass some sort of velocity, right? So velocity as well. Velocity, so I multiply by dx with the velocity, and here as well, times velocity. And you can do a lot of more methods. So let's give it a shot, run, nothing to print, car.print all properties, and there you have it, position 0, type BMW, and so on. Now, let's say I would want to move the car once, so move backward, right? Let's move it backward. Let's see what will happen. -1 with a velocity of 1, then print all the properties, and there you have it. The position is at 1, and there's a mistake. What is the mistake? It's that dx is -1. Dx should be positive, so as such. Okay, let's do an apps to avoid confusion. So if I put -1 here, it won't change. So this will be read as its positive counterpart. And here as well. So velocity as well, in case a user entered a negative value. So let's put an apps. Apps means absolute value. And there you go. Position is at -1. Let's say I would want to move the car multiple times backwards. So for I in range 0, let's say 100 times. There you have it. It is at position -100. Now let's say I would like to move the car forward, move forward with dx1, but this time velocity 1000. So now print the properties. There you have it. It is at position 900, and so on. So this is basically how you work with classes in Python. It's as simple as that. Okay. Now, one more thing worth noticing is that in Python you have a lot of modules to work. Let's say you'd want to create your own module. So what is a module? It's a file. So let me create a file, new Python file, and call it my own module. Okay, this is a Python file. And let's say I want all my functions and my classes to be in one clean file, like I want to separate them. Okay, how do I do that? Well, let's say I don't want my vehicle to be here because it looks annoying. Okay, so what do? I could take it as such, paste it here, and then we have an error here because vehicle is not defined. It cannot recognize classes in another file, so I have to import the module. Okay, so my module should be imported. How do I do that? As simple as import my own module. Oh, so it is in it should be in the same directory. So let me put it back here. Okay, it's in the same directory as main, which is the function which is the script I'm working with. So now it should be able to recognize it. My own module. Let's say the name of your module is big and you would like to refer to it in a smaller shorthanded way. So you can give it a nickname as M or as MOM, my own module. So as you can see, vehicle is still highlighted as red. So how do I refer to it? It's as simple as mom.vehicle. Okay, and we now could be able to compile. This also works for functions. So let's say you have a function as well here called calculator, and you have two numbers and let's say an operator, whatever. And if operator is multiply, then return, I don't know. There's an error here. It's not a semicolon, it's a colon. Return A times B. And let me copy paste this 4 more times. Do a divide. And cast this. So I'm creating a simple, very basic calculator. Plus and a minus. So a plus and minus. Else, return. What do you want to return if there's no valid operator? Let's first of all print invalid operation and return minus 999. So let me just comment all those out just to show you that you could also work with functions as such. So let's say you would like to have your answer being MOM, this is how you refer to the function, dot calculator 4, 5, and a times. Run. Oh, there's nothing to print, so let's print it. Run 20. Divide 0.8 minus 1 and plus 9. Let's say I put a hat invalid operation. Okay? So this is how you work with modules. Next up is dates. How do I work with dates? So a date is a date, like it has a day, a month, a year, times, hours, minutes, seconds, and so on. So in Python, it's really easy to work with dates. Never been simpler. All you have to do is import datetime. So datetime is a built-in, sorry about that. Datetime is a built-in module in Python. It's there for you to use. You're free to create variables in the datetime module. So how do we do that? Let's say I'm interested in getting the date of this instance right now. So all I have to do is take date is datetime, which is the module, dot datetime, which is the object, dot now. So what is the date now? Now print date. And there you have it. This is the date right now. Let's say you're interested in extracting the hour, 21 minutes, 37 and second, 18. If you want to be more precise, you've got the microsecond, right? And you've got day, the month, and the year. Okay? Now, let's say you're not comfortable with this format right here. You want, let's say, now this is a 24-hour format. You would like to change it to AM or PM. Now, for that, you would have to use something called the strftime function. So, .strftime, and you would specify what do you want. Like, there's a lot of characters here to specify the mode of this function. So let's say you're interested in getting the AM or PM, so P right now. No, it's percentage P, sorry. Percentage P PM, right now it's PM, right? And you're interested in getting the hour in 24-hour format, so percentage H, or an AM PM format, it's 9 PM, okay? There's a lot of stuff you could do with this function, such as percentage A, which is the first 3 initials of the day, uppercase A, the full day, lowercase w is the weekday number, so 0 is Sunday, 1 is Monday, 2 Tuesday, 3 is Wednesday, right? Lowercase d gives you the day of the month, lowercase b gives you the first 3 initials of the month, uppercase b will give you the full name month, lowercase m will give you the month number, and so on. There's a lot of stuff you can do here. You also have percentage f, which is microseconds, and so on. Okay? Now let's say you want to create your own date, right? You're interested in creating a date with a certain day, month, year, possibly hours, minutes, and seconds. Okay? My own date is datetime. So this refers to the module, right? I could call it as D, and then I'll have to change this to D and D. Dot datetime again. And now you can create the datetime. So we start with, let's say, the year. Let's say I want to create a date in 2050. Month is October, and day is 3. And those are optionals, right? By default, there are zeros, as you can see here. Okay? I'm okay with this date. Now let's print it to make sure. And there we have it. Okay? Now you can also compare dates. So want to see if a date comes before or after. It's as simple as, is my date greater than the date right now? If it is, print my own date is ahead of time. Else, my own date is in the past. So run. It is ahead of time because we're currently not in 2050. Let's put 2017. My own date is in the past. Okay. That's it for dates. That's how you work with dates in Python. Let's talk about something else called JSON, or JavaScript object notation. It has nothing to do with JavaScript, the programming language. No, it's just a syntax or type of way for storing and exchanging data, most commonly used with APIs or databases. Okay. Now for that, you'd have to import the module called JSON as such. And there's two things you can do with JSON, or two things that are most done with JSON. It's receiving JSON or transmitting JSON. Okay? So if let's say you're receiving a JSON, which looks like, I don't know, most probably it looks like a dictionary. So this is why I said dictionaries are used with databases and APIs most of the time. Let's say you received a JSON, yes, which has a certain name key. Let's say the name is Mike Tyson, and it might have also age, which is 37. Did win, true, and I don't know, address Tahiti, for example. Okay, so let's print X. It's a string, of course. It's a string because I just defined it as a string. To verify, we have it's of type string. But this is how you receive JSON over the web, or I don't know, over APIs or any other communication scheme. This is how you most probably would receive a JSON. So let's say you'd want to convert it to something that makes more sense because you can't work with a string. You'd want to extract them, then do a lot of, string chopping or splitting, and yeah. To avoid all this, you can only use the JSON module and parse the JSON. So JSON.loads would allow you to parse the JSON. So let's print Y as such. There's a value error. Wait a second. So the problem is here. Key value pairs are also received in as a string. So let me do this. Let me run, and there you have it. This is your dictionary. Now to access the elements, name, Mike Tyson, age, 37. Now 37 is what? A string, right? So to make sure, type of Y of age is a Unicode, not a string. So you can cast it, I think, int. Now it's an integer. Now let's say you want the age plus 10. Oh, so this is a type. Sorry about that. It should be int. And there you have it. It's a 47. Okay? Let's say you want the did win. Run. You can't cast it true to a did win. I meant to cast it as a bool. Could you cast a bool? Yes, you could. Yes, you could. So, yeah, because it's of type Unicode, so you need to cast. You need to cast it to a Boolean to work with. Okay, which means you could do also a not, which is a false. Okay, and the address is a should be casted to a string. Okay, there you have it. Now this is how you'd receive a JSON over the web. You'd use JSON.loads to convert it to something useful. Let's say you would want to do the opposite scheme. Let's say now I have Y, I processed it. So let's say now I want to, my job is a database that checks if any information is correct or wrong. So now I have my Y. Now let me do some stuff with the Y. Let's say Y did win. He did not win, so let me flip it. So casting, then putting a not, or whatever he did, I'm going to invert it. If he didn't win, I'm going to say he won, Mike Tyson. And if he won, I'm going to say he did not win. So I'm going to have to invert the did win value. So not is y did win. Okay? And now we flipped it. Now let's print y to make sure. It's a false, okay? True, false. Now I did this flipping. Let's also change the address of this guy. So y address is no longer Tahiti, it's in Toronto. Run, no trouble, then print y. And there you have it, okay? Now I'm ready to send the information back to where it came from. So how do I do that? Let's say x now is, I need to convert it to something of JSON type. So JSON.dumps y, and there you have it. Print x to make sure. There it is. Okay? Toronto, false, 37, Mike Tyson. And that's it. That's all you need to know how to work with JSON. Okay? Now, one more important concept is did try. Try, except, finally, blocks. What are those? They fall under the error handling section. So what is error handling? Let's say I did some sort of error, which is, let's say I divided by 0, 0 division error. Or I don't know, printed something that is not defined, name error. Or let's say I added an integer with a string, type error. So all those are types of error, and as you can see, the error might be annoying to some programmers. So what is the way around this? All you have to do is try a certain block of code that might or might not work. Then, if you're not sure what the type of the error is, do an except without mentioning the type of the error. So print, there is an error that I do not know of. Okay, so run, and there you have it. Notice that Python did not raise the error as before, it raised your own error, your custom error. Okay, now let's say you're sure of the error, you know what the error is, or you'd like to have different messages for each error. So except type error, print, oops, there is a type error. So run, and there you have it. Let's say you did another type of error, for instance, dividing by 0. There is an error I don't know of because it's not a type error, so it will go by default here. Now let's do the divide by 0 error, 0 division error right here. Print, you just divided by 0. Run, and there you have it. So this is how you handle errors in Python. And there's also a block called finally. It's a keyword. And right here goes code which, regardless if there's an error or not, will be executed. So no matter what, I will be in this block. This should always be printed. There you go. There's an error. There's another type of error. And there's no error. Okay? So that's it for try, except, finally blocks. Let's talk a bit about FileIO. What is a FileIO? It means how to read from a file, how to create files, write, append, and finally delete. So first of all, how do we create a file that doesn't exist? All I have to do is use open a file, so call this file.txt, and open it in which mode? As you can see, we have a mode. So you have write mode, read mode, and append mode. So once you're creating a file, if it doesn't exist, it's preferable to use the write mode. And at the end of the day, after you're done, just close the file for safety. So if I run this code right now, you will see a file over here being created called file.txt. And there you have it, it's empty. Now, how do I write to a file? Well, all we have to do is f.write, and here we could place this is sentence number 1. Run. Sorry about that. Let's open the file, and there you have it. Okay. Now, let's say I want another sentence. Let me copy this. 2, run, and it's being placed next to it. So how do I configure this? I should go back to the first sentence and insert \n, which is a special character to go to a new line. Run, and there you have it. Okay. Let's say I want 100 lines. So for I in range 0, 100, f.write, this is line number I, and a period with a \n. Run, there you have it. Okay, now there's a problem here. What happens every time I run the file? It doesn't write over the file. No, it creates a new file. It overwrites on the file. So as you can see here, we have 100, and I ran it twice. So let me show you what I mean. Let me put instead 10 lines, run. I have 10 lines. If I run it again, it's not going to overwrite on top of those lines. No, it's going to recreate the file. So how do I write over a file? How do I append? I just open it in append mode. So run, we have it twice. Run, we have it 3 times. So this is the 3rd time. And this is the 2nd time of running the code. And this is the 1st time. Okay? Now what happens if a file doesn't exist and I open it in append mode? Let me delete the file. Let's delete. So we'll delete. Delete. Okay, so this is not deleting. I close the file right now. Let me delete it. So now it's deleted. Okay. Now let me open it in append mode. What will happen? Run. It will create it for us. Okay. Run again. Overwrites on the file, or writes on top of the file. Overwrites means to recreate the file. Okay, so now we saw how to create a file, read from, write to a file, and append to a file. Now, how do we read from an existing file? Let me just insert 9 lines as such. There you go. How do we read from a file? Nothing. We just open it in read mode. And how do we extract a certain sentence or a certain character from a file? All you have to do is type in fread. There you have it here. Okay. Now, fread is a string that contains all the characters of the file. So the length is 209. We've got 209 characters in this file. What if I want to be more flexible and I want, let's say, some characters, not all of them. Let's say I want to extract the first 5 characters, which are this only. So 50 characters. This is, all those are of size 50. Okay. This is how you read character by character, or a substring of your file. Let's say you'd like to read a line from a file. Read line. This is line number 0. Again. Let's do it again. See what happens. This is line number 1. So it reads line by line. Okay. Let's do something else. So for line in f print line. There you have it. Okay? Line by line. Good. Last but not least, how do we delete a file? So for that, you would need a module called OS, and all you have to do is os.remove file.txt, run, and it's deleted. Okay? You can also check if a file exists or not using the OS. So print os.path.exists. Does this file exist? File.txt? No, it does not. Let me create it. Open file.txt, write, and f.close. It exists. Okay? Now, let's say you would like to delete a certain directory from, you have a directory called foo, and you would like to delete it. How do you delete it? Well, all you have to do is run os.remove directory, rmdir, not file, foo, or foo as such. Run, and it's deleted. Remove file.txt again, and it's gone. Okay? And what happens if you open a file that doesn't exist? F is equal to open file.txt, write, or read from a file that doesn't exist. You have an IO header. So a good way of dealing with this is try catch or try except. In other programming languages, it's called try catch. Except IO header, print file doesn't exist. Run, so file doesn't exist. Okay? So that's basically how you work with files. This is all you need to know to start with Python and start writing good code, working with other modules such as NumPy and sklearn. There's plenty of Python modules that are really good and easy to learn, and they save a lot of programming time. Okay? Thank you for watching, and I'll see you in future lectures.